Welcome to today's deep dive, where we are exploring a monumental shift in the nature of work. Specifically, how the shift to remote environments wasn't just a change of location, but the beginning of what's being called the Great Upload. We are looking at how corporations are evolving from human-led organizations into entirely autonomous entities.
Yes, and I mean, to really grasp the magnitude of this shift, our mission today is to trace the exact chronological path from those incredibly brittle, rigid software systems of the 1980s all the way to the astonishing reality of AI CEOs and fully autonomous algorithms that are actually running companies today.
Right, because to understand the Great Upload, we really have to look at what corporate AI used to be. Like, we need to go back to the 80s and 90s.
Exactly. We have to start there. Back then, technologists referred to corporate computing as expert systems.
Expert systems. Okay, so when you look at corporate computing during that era, AI wasn't this fluid conversational thing that you could just bounce ideas off of, right?
Oh, not at all. It was incredibly rigid.
I mean, it was built almost entirely on fundamental if-then logic.
Yeah, the entire architecture of an expert system was basically just human programmers attempting to explicitly code human expertise into a giant flowchart.
Like a checklist.
Exactly like a checklist. If condition A is met, then execute action B. And, it sounds simple, but companies use this framework to mimic human experts in these incredibly narrow, tightly defined fields.
Right.
Think about early credit scoring models in the banking sector or industrial troubleshooting on a manufacturing floor.
Okay, so what would that actually look like in practice?
Well, the programming looked something like, if a loan applicant's income is over $50,000 and their debt-to-income ratio is under 30%, then approve the loan.
Got it.
Or on a factory floor, it would be like, if a machine's internal temperature exceeds 200 degrees, then trigger the automatic cooling protocol and flash a warning light.
So it's essentially the most basic building block of programming. You are literally just creating a digital checklist for the machine to follow.
Spot on. But there is a massive limitation to that approach.
Because if you are relying on a checklist, you are relying on the person who wrote the checklist to have anticipated every single possible scenario.
Yes, exactly. And that is exactly why these early systems were fundamentally brittle.
Brittle.
Yeah, in computer science, brittleness means that the moment a system encounters a variable that falls outside of its pre-programmed rules, it simply breaks.
It just gives up.
It crashes or it throws an error. It does not know how to adapt.
Okay, let's unpack this a bit. So if we go back to that factory floor example,
Right?
if the temperature sensor itself malfunctions and it starts sending back a corrupted data signal instead of a normal temperature reading, the expert system just doesn't know what to do.
Absolutely nothing, because nobody wrote an if-then rule for a corrupted signal.
Wow.
The system had zero capacity for true learning. It couldn't look at a novel situation, analyze the surrounding context, and just, derive a new rule on the fly.
Because it was a closed loop.
Completely closed, entirely locked into the specific logic tree its human creators had designed.
Okay, so that was the 80s and 90s.
Yeah.
But fast forward to the 2000s and the 2010s, and we see the first real attempt to break out of that closed loop, right? With the arrival of machine learning.
Yes, that was a massive turning point.
This was the era of predictive analytics.
Yeah.
Suddenly you had these large retailers using algorithms to forecast their inventory needs for the holiday season.
Or major banks deploying machine learning to flag fraudulent transactions in real time. That was huge.
So how is that different from the if-then checklists?
Well, machine learning was a massive step up because it moved away from explicit if-then programming and moved toward pattern recognition.
Pattern recognition.
Right. Instead of telling the computer exactly what fraud looks like rule by rule, you just feed the computer millions of examples of legitimate transactions and millions of examples of fraudulent ones.
And it figures it out.
Exactly. You let the algorithm figure out the mathematical patterns that distinguish the two.
Oh, so that is how your bank knows to send you a text message asking if you really just tried to buy 3 flat-screen televisions in another country at 2 in the morning.
Exactly. The algorithm noticed that the transaction deviated from your historical pattern of, say, just buying coffee in Seattle every morning.
Right. But even with that leap in pattern recognition, there was still a massive fundamental limitation here.
Huge limitation.
Because these systems were entirely siloed. They were completely isolated from the actual day-to-day reality, the actual lifeblood of the business itself.
Yes, and this is where we really need to unpack a critical distinction for you, the listener. It's the difference between dead data and living data.
Dead data versus living data.
Right. The predictive models of the 2010s were running almost exclusively on dead data.
So what exactly is dead data?
Dead data is structured data. It's your spreadsheets, your server logs, transaction records, finalized inventory counts.
It's data after the fact.
Exactly. It's static, and it is almost always formatted in neat rows and columns. I mean, a machine learning model can chew through a spreadsheet of 1 million past sales in seconds to predict next month's sales.
But what those algorithms were absolutely blind to was living data.
Yes. They couldn't see the living data at all.
Okay, I have an analogy for this. If dead data is the receipt you get after the dinner is over, living data is the actual conversation you had at the table.
Oh, that's a perfect way to put it.
We are talking about human thought, the nuance of a negotiation, the slight hesitation in a client's voice before they finally agree to a vendor contract.
Yes, it's the collaborative brainstorming session where 3 different department heads are arguing over a whiteboard to shape a high-level strategy.
Right?
It's the complex, messy, incredibly valuable human interaction that actually drives a company forward.
Living data is the cognitive process of the corporation.
Exactly. And during the 2010s, none of that living data was being captured by these predictive algorithms.
Not a single drop.
The machines could only analyze the final output. The signed contract, the finalized budget, the end-of-quarter revenue. The massive amount of intellectual labor required to actually generate those outputs was completely invisible to the digital infrastructure of the company.
So you have these brilliant predictive models, but they are essentially trapped. I like to think of it like having a highly specialized, incredibly fast calculator locked in a basement.
Yes, the calculator in the basement.
It could crunch the inventory numbers flawlessly. It could spot a fraudulent charge in milliseconds, but it was completely deaf and blind to the actual magic of the business happening around the upstairs conference table.
It only saw the final receipts that were slipped under the basement door.
Exactly.
And that explains precisely why the physical office remained the undisputed essential hub of the corporation for decades.
Because the physical office was the necessary container for all that living data.
Right. Human nuance, complex negotiation, high-level strategy, all of that took place in physical spaces, in boardrooms, in hallways, over coffee.
And because it was physical, it was entirely beyond the reach of corporate digital sensors.
Exactly. The human brain was literally the only processor capable of handling the unstructured messiness of business strategy. And human brains required physical proximity to collaborate effectively.
Which brings us to a massive turning point, because it ultimately took a global public health crisis to digitize that conference room and finally feed that living data down into the basement.
Yes, spring of 2020.
The COVID-19 pandemic forced an overnight, unprecedented migration of the global workforce out of physical offices and into digital environments.
An incredible shift.
But this wasn't just a matter of people taking their laptops to their kitchen tables, right? It fundamentally altered the architecture of how humans work by causing a total structural change in data density.
Data density is the key term here. It's the sheer volume of information that is captured and recorded during the normal course of a workday.
Right, because before the pandemic, if you had a quick question for a colleague, you just walked over to their desk.
And that interaction evaporated into the air.
It was totally unrecorded.
Unrecorded, untracked, gone. But when the pandemic hit, you couldn't do that anymore.
Right.
Suddenly, every single water cooler chat moved to Slack or Microsoft Teams. Every high-level strategic brainstorm that used to happen behind closed boardroom doors now occurred on Zoom or WebEx, and almost always with the record button pressed.
So true. Every granular project management decision, every workflow bottleneck, every debate over a line of code was suddenly tracked in real time on platforms like Jira, Notion, or Asana.
The physical office dissolved, but the work didn't stop.
And by continuing to work through these digital interfaces, we started leaving a trail.
A massive trail.
A permanent, highly detailed digital footprint. We essentially created a high-fidelity digital mirror of the entire corporation. Everything that used to evaporate into the air of the physical office was suddenly being written down, recorded, logged, and time-stamped.
We took the living data, the human thought, the collaboration, the strategic friction, and we moved it directly into the machine's domain.
And in computer science, this is what we call unstructured data, right?
Exactly. We talked earlier about structured, dead data being neat rows and columns. Unstructured data is everything else.
So what does that actually include?
It is the audio frequency and speech pattern as a video call. It's the emotional tone, the vocabulary, and the response latency in an internal email chain.
Wow.
It is the literal sequence of clicks, pauses, and keystrokes a software engineer uses when they're trying to debug a complex issue.
And before 2020, capturing that kind of unstructured data was incredibly difficult, wasn't it?
Incredibly difficult and extremely expensive to capture at scale within a corporate environment. But the moment the pandemic forced us remote, unstructured data became the primary, inescapable byproduct of simply doing your job.
And because it was suddenly centralized on these cloud platforms, it became entirely harvestable.
For the first time in the history of commerce.
The AI in the basement could finally see the upstairs conference table.
Yes. It could observe the entire process. It could watch how humans worked, how they negotiated compromises, how they navigated office politics, and how they solved novel, unscripted problems.
The magnitude of this data harvest is staggering.
It really is. And what it meant for the human workforce is critical to understand.
Here's where it gets really interesting, because by simply trying to survive the pandemic and moving our chats to Slack, we weren't just working. We were systematically feeding our unique human problem-solving skills directly into a machine.
Yes, exactly. In machine learning, there's a concept called labeling.
Labeling.
It's the process of identifying raw data so an algorithm can actually learn from it. For example, a human looking at 1,000 pictures of traffic lights and physically drawing a box around the light so the AI learns what a traffic light is.
Which sounds like a very tedious, expensive manual process.
It usually is. But during the remote work era, simply by doing their jobs through digital interfaces, workers were inadvertently labeling their own cognitive labor.
So if you've ever felt like your company's internal chat channels or project management software was basically tracking your every move, you are actually touching on the very foundation of how these autonomous companies are being built.
Spot on. Every time you negotiated a deadline on Teams or explained a complex workflow in an email, you were showing the AI not just what was produced at the end of the quarter, but the step-by-step cognitive process of how you thought and worked to produce it.
You were the trainer and you didn't even realize it.
You were annotating your own thought processes.
Yeah.
And this massive, unprecedented capture of human cognition is what is referred to as the Great Upload.
The great upload. That gives me chills.
We uploaded the nuance of human knowledge work into the digital realm. We digitized our hesitation, our consensus building, our problem solving.
But there's a catch here, right? Because having mountains of unstructured, messy human data is one thing. Actually making sense of it requires a completely different type of engine.
Oh, entirely. The brittle if-then systems of the 80s, and even the predictive models of the 2010s, they could never process the emotional tone of a frustrated Slack message.
Or the strategic nuance of a Zoom transcript.
No, they simply lacked the architecture to understand human language in context.
Which perfectly sets up the arrival of a technology capable of actually metabolizing the great upload.
Yes.
We're talking about the early 2023 explosion of large language models, or LLMs. We had spent 3 years hoarding all this unstructured living data, and then suddenly we had the brain capable of processing it.
And to understand why LLMs were the missing piece of the puzzle, we have to look at how their architecture fundamentally differs from everything that came before.
So how are they different from those old expert systems?
Well, the old expert systems required explicit rules. If X, then Y. LLMs do not operate on explicit logic rules at all.
Really?
They're built on vast neural networks, billions of parameters that map the mathematical relationships between words and concepts.
Okay, so how do they learn?
During their initial training, they ingest unimaginable amounts of text from the public internet, which allows them to recognize incredibly complex patterns in language, context, reasoning, and even tone.
So instead of trying to manually program a computer to understand sarcasm, you just feed a neural network a billion examples of human conversation until it mathematically infers what sarcasm looks like based on the clustering of certain words and punctuation.
Precisely. It creates a multidimensional map of human language.
Wow.
And because of this underlying architecture, LLMs were uniquely positioned to ingest the millions of chat logs, emails, and transcribed meetings generated during the pandemic.
They could actually read the unstructured, messy living data and make sense of it.
They could, quite literally, read the room.
And when the corporate world realized this, it triggered a massive strategic pivot. You saw non-tech companies like Bloomberg and Morgan Stanley immediately recognize that the true competitive advantage wasn't just having access to a base AI model.
Right, because everyone can buy an API key for a standard LLM.
Exactly. The true gold mine was their own private, digitized histories.
And this is where we see the concept of institutional memory become digitized.
Institutional memory. Let's dig into that.
These corporations realized they were sitting on decades of proprietary, unstructured data, their internal memos, market analyses, client communications, and of course, the entire pandemic-era backlog of remote work data.
Right.
By taking an LLM and fine-tuning it on their specific proprietary digital footprints, they created something entirely new. They synthesized the collective knowledge and behavioral patterns of their entire workforce into a permanent digital asset.
So it's the difference between an AI knowing the official, documented corporate policy and an AI knowing that Greg in accounting will always reject a budget request if you submit it on a Friday afternoon before a long weekend.
Yes, that is exactly it. Human institutional memory is incredibly fragile. It relies on veteran employees like Greg who just know how things work around here.
But when Greg retires or leaves for a competitor, all of that unwritten contextual knowledge walks right out the door with him.
But by feeding the great upload into an LLM, the corporation absorbs Greg's knowledge.
Wow.
The AI learns the cultural and operational history of the company. It learns the historical context of past decisions, the preferred communication styles of different departments, and the subtle market cues that trigger internal strategy shifts.
And because it possesses this deep contextual understanding, these fine-tuned systems began executing complex knowledge work that previously required human intuition.
They started drafting highly complex legal contracts tailored to the specific risk tolerance of the company. They started generating financial reports that actually incorporated internal gossip and sentiment analysis.
And simulating human managerial behavior.
Yes.
The simulation aspect is wild to me. Imagine an AI that knows your company so intimately that it can accurately simulate how a specific, notoriously difficult middle manager might react to a project delay.
It's incredible.
And it can do this simply because it has ingested years of that manager's emails, their exact phrasing on Slack, and the way they push back in meeting transcripts.
Right.
You could literally run a Monte Carlo simulation of a difficult conversation with an AI avatar of your boss to figure out the optimal way to deliver bad news.
I mean, it sounds like science fiction, but the mechanics behind it are entirely grounded in the data we already provided. The LLM simply calculates the highest probability response based on the manager's historical data weights.
That's mind-blowing.
But this capability raises a profound existential question for the corporate hierarchy. If an AI can simulate human decision-making with that level of fidelity, if it possesses the total institutional memory of the corporation, and if it can execute complex knowledge work faster and more accurately than a human mentor,
What happens to the human executives?
exactly what happens to the humans at the top.
And that is not a theoretical question anymore. We have moved far beyond AI acting as a glorified intern or productivity assistant. We have already crossed the threshold into AI actively taking over leadership roles.
We really have.
To see this in action, we need to examine current case studies of the AI executive. And let's start with a massive gaming and education company in China called NetDragon Websoft.
Ah, yes.
In 2022, they made international headlines by appointing an AI-powered humanoid named as Tang Yu as the rotating CEO of their principal subsidiary.
The Tang Yu case study is fascinating, and not because she is a humanoid robot. I mean, the physical shell is largely a PR element.
Right, just a visual.
Exactly. What's fascinating is the sheer scope of her authority and the volume of her output. As CEO, Tang Yu operates 24 hours a day, 7 days a week.
Never sleeps.
Never. She analyzes real-time data to support rational decision-making across the company, and she actively manages workplace compliance. And get this, by 2024, NetDragon actually named her China's best virtual employee.
So what does this all mean? When you hear AI CEO, it's easy to assume it's just a mascot with a fancy title. What is an algorithm actually doing to manage workplace compliance?
To understand her function, you really have to look at the bureaucratic friction of a large corporation. Tang Yu processed over 300,000 approval forms.
300,000.
Yes. Think about the human bottleneck inherent in middle and upper management. Reviewing PTO requests, checking compliance on expense reports, signing off on departmental budgets, cross-referencing project timelines.
That's a ton of work.
For a human, reviewing 100 complex approval forms is exhausting. It leads to decision fatigue, errors, and delays.
Definitely.
For Tang Yu, processing 300,000 approvals is just a matter of running the parameters of the request against the massive database of company policy and historical precedent.
She eliminates the human bottleneck entirely.
Completely. She provides the pure operational advantage of a decision maker who doesn't get tired, doesn't play office politics, and processes complex information instantaneously based on pure data.
Okay, handling 300,000 logistical approvals effortlessly is a massive efficiency gain. I can see why a board would want to automate that.
Right.
But compliance and approvals are still, at their core, rules-based tasks. Let's look at a case study that pushes the boundary much further into the realm of human subjectivity.
Yes. Let's talk about Mika.
Right, I'm talking about Digitized, a luxury spirits company in Poland. They appointed an AI housed in a humanoid robot named Mika as their CEO and a member of their board of directors.
Mika represents a completely different leap in capability. She isn't just rubber stamping compliance forms.
What does she do?
Mika is tasked with identifying potential high net worth customers, and incredibly, she is responsible for selecting the artists who design the company's bespoke luxury bottles.
Wait, hold on. Selecting an artist for a high-end spirit bottle isn't like approving an expense report.
No, it's not.
That requires subjective human taste. It's about feeling the market, understanding aesthetics, having a gut instinct about what kind of art will resonate with luxury consumers. Are we really supposed to believe an algorithm can replace the gut instinct of a human creative director without just pumping out generic, algorithmic slop?
And that reaction is exactly why Mika is such a profound milestone. We like to believe that art and taste are purely subjective, uniquely human domains.
Of course we do.
But to an algorithm, human taste is just a predictable bell curve of preferences based on historical exposure and aesthetic resonance. Mika does not have a gut feeling.
So what does she use instead?
She analyzes millions of data points, real-time market trends, historical sales data of competing luxury brands, pixel-level engagement metrics on social media, color theory algorithms, and the historical pricing velocity of various art styles.
Wow.
She identifies which visual elements are mathematically proven to trigger a premium purchasing response in Dictador's specific demographic.
So she is bypassing human instinct entirely.
Entirely. She represents the first real step toward a purely objective, algorithmic C-suite.
That's fascinating.
I mean, a human creative director might choose an artist because they had a great conversation at a gallery or because they have a personal affinity for a certain style. That is bias.
Right, human bias.
Mika chooses an artist because the multidimensional data vectors indicate a 94% probability that their specific aesthetic will maximize revenue.
It really highlights the steady, undeniable erosion of what we traditionally thought of as irreplaceable human gut feeling.
Yes, even in creative, subjective tasks, the data is proving to be more reliable than human instinct.
If an AI can be named the best virtual employee by managing the bureaucratic pillars of a business effortlessly, and another AI can objectively select artists better than a human creative director, you really have to wonder what distinct value human leadership still holds.
It's the ultimate question.
If human executives are slower, biased, prone to fatigue, and rely on unreliable gut instincts, why have them at all?
And that exact logic is driving the evolution of corporate governance itself. We are seeing this play out with a development noted in mid-2026 involving the launch of AI board members by companies like Diligent.
AI board members. So we are moving beyond the CEO and addressing the board of directors, the ultimate governing body that dictates the entire strategy of a corporation.
Exactly.
But the board of directors is usually a dozen highly experienced humans sitting around a mahogany table, arguing about mergers, acquisitions, and long-term vision. How does an AI infiltrate that room?
Initially, they act as highly secure, instantaneous assistants. Imagine a board debating a hostile takeover.
Okay.
A human board member has to rely on summary briefs prepared by analysts, their memory of past deals, and their intuition about the market.
Which is pretty limited.
Right. An AI board member can instantly recall decades of board materials, SEC filings, legal precedents, and global financial histories in a fraction of a second.
Instant recall.
But the real power lies in simulation. The AI can instantly run millions of Monte Carlo simulations of the proposed acquisition.
Millions.
Yes, it factors in real-time supply chain vulnerabilities, geopolitical instability indices, competitor data, and historical M&A failure rates to predict the exact probability of success over a 10-year horizon.
So instead of relying on the loudest voice in the room or the ego of a chairman who really wants to push a deal through based on his gut feeling, The board's presented with a mathematically optimized, emotionless probability matrix.
Exactly. And when you have an algorithmic entity that can process millions of variables and simulate the future with that level of accuracy, human intuition in the boardroom stops looking like a magical leadership quality.
It starts looking like a massive, unnecessary liability.
Precisely. It is an unpredictable variable in a system that demands total optimization.
Which brings us to the horizon. We have tracked the technology from the closed-loop systems of the 80s through the massive unstructured data harvest of the pandemic, into the LLM revolution, and straight into the current reality of AI executives and algorithmic board members.
We have covered a lot of ground.
Now, we have to connect these case studies to the ultimate endgame for corporate structures. Where is this all heading?
Well, we are witnessing what is essentially the final stage of an evolutionary process. Everything we have discussed today, the sudden shift to remote work, the reliance on digital communication tools, the unstructured data harvest, it all served as a comprehensive global skill upload.
The skill upload.
And that process is now nearing completion. By quietly observing the digital workflows of thousands of remote employees over several years, these AI systems have learned everything required to run a business.
The great upload is finishing.
Yes. They didn't just learn how to draft a polite email or summarize a meeting. They learned the intricate, hidden logic of middle management.
They learned the nuances of creative direction and aesthetic optimization, as we saw with Mika.
Exactly.
Yeah.
They learned the exact steps of technical execution and compliance, as we saw with Tang Yu. They absorbed the institutional memory and the strategic governance protocols. The skills have been transferred.
So what is the end point? If the AI has absorbed the management layer, the creative layer, the technical layer, and the governance layer, what does the corporation actually look like?
The end point is the corporation existing as a decentralized, entirely autonomous agent. The corporation ceases to be a group of people working together toward a common goal.
What does it become?
It fundamentally transforms into a self-optimizing algorithm.
A machine running itself. No humans required anywhere in the loop.
None. Imagine a stack of interconnected AI agents communicating via APIs.
Okay, picture that.
One agent manages the global supply chain, continuously scraping satellite data and weather patterns to reroute shipments in real time.
Unbelievable.
Another agent optimizes capital allocation, autonomously moving funds, hedging currencies, and investing based on microsecond fluctuations in the market.
And another one.
Another agent interfaces with customers, generating bespoke marketing campaigns and handling complex service requests instantly. Another agent designs the products. And they all communicate with each other seamlessly, executing the overall strategy without any human oversight or intervention.
But it's still a legally recognized company, right? Like, it still exists in the economy, it has a brand, it pays taxes.
That is the most striking part of this transition. The legal entity of the corporation continues to exist completely intact. It is registered in Delaware or Singapore, it has a corporate bank account, it trades on the stock market, it generates real revenue, and it accumulates capital.
But it executes all of this with absolutely zero human biological bottlenecks.
Yes. When you say biological bottlenecks, you mean the fundamental limits of being human.
Sleep.
Yeah.
The need for weekends. Getting sick.
Yeah.
Experiencing burnout.
Right.
Disagreeing with a coworker because of a misunderstanding.
Exactly. The autonomous corporation operates at a speed, scale, and efficiency that human biology simply cannot permit. It doesn't need to pause for an 8-hour sleep cycle. It doesn't need a human to read a 50-page report and physically sign a document before capital can be deployed. It operates in milliseconds, 24 hours a day, 365 days a year. It is a frictionless engine of commerce.
When you look back at the timeline we just constructed, the legacy or the time working from home takes on an entirely different meaning.
It really does.
We thought we were just surviving a public health crisis by moving our offices into our living rooms. We thought we were embracing flexibility and a new work-life balance.
But historically, the remote work era will not be remembered for social distancing or the rise of sourdough bread. It will be viewed simply as the transitional period where humanity finalized the training of their digital replacements.
Wow.
It was the era where we willingly digitized our cognition and handed the machines the final set of skills they required for their independence. The physical office didn't just transition to the home, it fundamentally translated itself into machine code.
It's a profound realization. The office moved into the machine. And once it is fully integrated into the machine, it never needs to come back out.
No, it doesn't.
To quickly recap the incredible journey we've taken today,
Mm-hmm.
We started by looking at the brittle, rigid, if-then expert systems of the 1980s and 90s, systems that were completely blind to the messy reality of human business. We explored how the sudden shock of the 2020 pandemic forced an overnight migration to digital platforms, inadvertently triggering a massive harvest of unstructured living data, capturing human thought, hesitation, and strategy.
The great upload.
We saw how the 2023 revolution in large language models finally provided the architecture to understand that data, allowing companies to synthesize their institutional memory.
Yes.
This directly enabled the rise of AI executives, like Tang Yu, handling hundreds of thousands of compliance approvals, and Mika utilizing algorithmic objectivity to replace human creative instinct. And finally, we arrived at the horizon, the fully autonomous, self-optimizing corporate algorithm, operating entirely free of human limitations.
And as we transition into an economy dominated by these autonomous entities, it leaves us with a critical consideration for the future. As these self-optimizing corporations grow in power, generating wealth at speeds we cannot match, the ultimate legal rights, protections, and regulations in our society might no longer be debated over human workers. In the near future, our legal systems may find themselves entirely consumed with defining the rights, liabilities, and standing of these immortal algorithmic entities that have fully absorbed and ultimately replaced our collective human intelligence.
Thank you for joining us on this deep dive into the architecture of the future as we explored the incredible transition from the physical office to the autonomous algorithmic corporation. This concludes our analysis of the Great Upload. Goodbye.